Welcome again. Now I'm still on my Geography Paper 1, November 2024, but now I'm gonna look at Mapwork. You know, I like Mapwork so much. I just enjoy doing Mapwork, and I want to make sure that I simplify it so that you understand. You understand Mapwork. This is where you're supposed just to collect marks. Okay, so Mapwork 2024 section B, we are going to do this. Then after that, we call it a day. Geographical skills and techniques, general information on Leadsmith. Leadsmith is a seat of Utukela, district of KwaZulu-Natal. It is situated along the Cape River. The climate is warm and temperate, with the highest rainfall recorded in summer. The average annual temperature is 17.3 degrees Celsius. The average annual precipitation is approximately 1,057 millimeters. This climate provides ideal conditions for agricultural raw materials. So whenever you are doing map work, the first thing that I emphasize is please go the general information, go through the general information. Why am I saying that? Because the general information, what it does is there is information that you can actually use to answer some of the questions, and also you need to have a better understanding in terms of where is the area located, what is the climate, what is the province in which it is found, and so on and so on. So this is very important. You need to go through the general information, and also you can see the georeferencing of the information here, where the location, the coordinates where it is found is very important. You need to go through this first before you attempt to answer any Mapwork question. Go through the general information. Okay, let's move on. The closest town closest to Leadsmith. This is our map. Okay, boys and girls, this is our map. This is our map which shows Leadsmith, okay, extract of 2829 DB Leadsmith. So the first question reads, the town closest to Leadsmith is. So when you look at your map, you want to find out the town that is closest. I want to show you something. Can you check here? We have got Kleinco, 36 kilometers. We have got Newcastle, 98 kilometers. What else do we have? We have got here another town that is Colenso, 23 kilometers. So the information is there. You have also Harrismith, 73 kilometers. So the question is the town closest to Leadsmith. So you check here. You can see I've checked here, I've checked here, I've checked here. I want to see which one has got less kilometers. That's the one that is close. So which means if I check here, I'll get my answer as D, which is Colenso. Why am I saying Colenso? It's 23 kilometers. It's 23 kilometers. You can see here. If you go to Harrismith, it's 73. If you can go to Glencoe, it's 36. If you go to Newcastle, it's 98. So the correct answer there is what? Colenso, 23 kilometers. Okay, the answer there is D. So whenever you are doing this, please make sure that you use the information that is at your disposal. Go through the map, try to look for that information. You see we have got here, that is Colenso. What is option Colenso there? Then the feature located at grid reference 283132. 283132. Remember, before I attempt to do this question, this is your map, your line of latitude. We are at latitude 28 degrees, 31 minutes south. This is where we are at the top. So your latitude, they increase going southwards. The degree remains the same. The only thing that is changed in terms of our latitude is the minute. Here we have got 28, 31 minutes south. So it means here is 32, 33, 34, 35. That's why we have got 36 here at the bottom. So what is changing is only the minute. Remember our rule, 1 degree is equivalent to 60 minutes. Okay, 1 degree is equivalent to 60 minutes. So what is happening is, we are saying now, let me just demonstrate, from 28 degrees to 29 degrees, there's 1 degree, which if we are to divide this latitude from 20 to 29, we can convert it into minutes. That gives us, let me say 15, 30 minutes, then 45 minutes. Then there we don't write 60 because it gets us to 29. You understand? So we are within the same degree, 28. Okay, but we are using minutes. We are saying now from 28, we have 31 to 36. This is the area that is covered in terms of our latitude. Okay, our longitude, we have got 29 here. 29, it increased towards the east, going towards our east. So we have got 29, 45 minutes. This is 46, 47, 48, 49. That's why we have got 50 here, because the number increased going towards the east. Okay, latitude, it increased going towards the south. Okay, 31, here we have got 36, but the degree remains the same. The only thing that has changed is our minute. Same applies with the longitude. The degree remains the same, 29, but what has changed is our minutes. So in each and every map that you come across, you will have your coordinates already given in degrees and minutes. The only thing that you have to do or calculate is your coordinates location in terms of seconds. That if you are asked to do it. Okay, so the question reads: the feature located in grid square, coordinates 28, 31, 32 seconds, and 28, 29, 47, 22 seconds east. So the easiest way to do this, guys, let me show you. The easiest way to do this, guys, is, okay, you check where is your 28, 31, 28, 31, which means here we have got 32. Anything behind 32 is 31. So which means the whole of this grid from here up to there is 31. So it's 28, 31. The only thing that we are looking for is the feature. We are given the degree, minutes, and seconds. So which means, okay, it's within this grid. Let's check the other, our longitude, 29, 47, 29, 47, 22. So this is 45, 46, okay? Okay, 45, from 45, 46, then we have got 47, then we have got 48, which means this is what? 46, this is 47, this is 48, this is 49. Remember, these are minutes. Okay, so we want to find out where our 2947 is. So this is still what? This is 245, behind 46, 45. Behind 47 is 46. Behind 48 is 47. Which means here is where, okay, this is the grid that we are more concerned with, because 2831 is still 2831. Here, 29, that is 47, is behind 48. So the question now is saying we want to find the feature that is there. So we have got two things that we have here. Let me show you how this is done. The simplest way how this is done. I'm going to write my latitude. That is 28 degrees, 31 minutes, 32 seconds south. This is my lat. I'll say lat. My longitude is 29 degrees, 47 minutes, 22 seconds east. Okay. The easiest way to find the exact feature, you do like this. You check your seconds, right? Let's all right, let me start by measuring the distance, the length of the grid. Let me start by measuring the length of the grid. The length of the grid. Let me start by measuring the length of the grid. The length of the grid. Okay. Sorry about that. Let me start by measuring the length of the grid. So we are saying now, if you measure from here up until there, what do you have? I've got 37 from here up to there. Well, let me measure going southwards so that I start from here. You can see where my ruler is. Where my ruler is. From here up to there, I've got 37, okay? Which means it's telling me that there is 37 millimeters, okay? I'll also do the same thing. From 47 to 48, I want to see my 47, there's 33. Here, there's 33 millimeters. So I want to find this feature. So what I'll do, I'll check my seconds for the latitude, which is 32. So I'll say 32 seconds over 60 seconds. Then I'll multiply it by 37 millimeters. Okay. I'll say 32 seconds over 60 multiplied by 37. Okay. I'll say 32, which is 32 seconds over 60 seconds multiplied by 37. What do I have? There is my answer, 19.7, which means I'll have something like 20 millimeters, okay? Then I'm also going, this is my latitude. I'm also going to do the same thing on my longitude. I'll take 22 over 60 seconds. I'll multiply it by 33. Where am I getting my 33? My 33 I measured from here up to there. That is 33. Then for the latitude from here up to that's 37. So what is the answer? 22 over 60 seconds multiplied by 33. What am I getting now? I got 12. So it means I'm going to get 12 millimeters. Okay. So if I'm going to measure, okay, I want to see where I've got my, from here, this is the box that I'm working with. So I'm supposed to get my 20. So my 20 is somewhere here. As you can see, my 20 is somewhere here. I'm just going to indicate with this. I've measured from the top. Then let's see where my 12 is. My 12 is somewhere here. What can you see? There is a perennial water there. There is a perennial water. There is a perennial water, which means my answer is B. That's how I got my B. That's how I got my B. Then moving on to 3.13. Moving on to 3.13. Moving on to 3.13, it reads, the mean magnetic declination of Weir was 2103 west of true north. So what I will do is I will check here on my map. The information is there. Here, can you see magnetic declination 21 degrees 3 minutes west of true north, July 2001. So I'll check from the options that are given, which means my answer there is what? C. Determine the total annual change of 2024. What is being asked is the total annual change. What will be my total annual change there? Which means I need to first find my difference in years. I need to first find my difference in years. What is the difference in years? Which means now I am in, okay, I'm going to use, which one can I use? Okay, I'll use 2024, that is there. I'll use 2024, that is there, okay? Total annual change of 2024. But usually when we are calculating the total annual change, we use for the current year. We use for the current years, okay? We use for the current year, which is, okay, let's say 2021, okay? Or for the, so that I don't confuse you, let me use 2024. But we usually calculate with the current year, okay? Which is 2024 minus 2001. Then we have got what? 23 years. We have got 23 years. That's the first thing that we do. The difference in years. What is the difference in years? Is what? It's 23 years. That is 2024 minus 2001. Then we have got what? We have got 23 years there. Okay. Then let's look at the next thing. We look at our mini annual change, which is 8 minutes. So that's what we are going to multiply with, okay? We are going to say first 2024 minus 2001, which is 23 years. But if it's come for this year, you are supposed to say 2025 minus 2001, which is equal to 24 years. Okay, let me do the right thing. Let me calculate with the current year. So we have got 24 years. So our 24 years, which is the difference in years, multiplied by the mini annual change, which is 8 minutes westward. Okay, what we have, 8 minutes westward, which means we are now calculating 24 multiplied by 8. What do we have? We have 192. We have got 192, okay, minutes westward, W. So 192, we cannot leave it like that because our 1 degree is equivalent to 60 minutes. So the moment it goes above 60, we have to change it or to convert it into degrees. So 60 plus 60, 120 plus 60, 180, which means we have got 3 degrees there. From 180, what are we left with? We are left with 12, which is 12 minutes what? Westward. So our answer there will be 3 degrees, 12 minutes westward. Where did I get that? Because if I multiply 24, because I'm using the current year, which is 2025, 24 years multiplied by 8, I have got what? 192 minutes westward. I cannot leave it in minutes because it's above 60 minutes. So I have to convert it into degrees. 1 degree is equivalent to 60 minutes. Okay. So 60 plus 60, 120 plus 60, 180. That makes us what? That gives us 3 degrees. Then from the 92, what are we left with? With 12 minutes. So our answer will be 3 degrees, 12 minutes westward. That will be our answer there. Okay. Then let's move on to the next one. Refer to the orthophoto. Refer to the orthophoto. Refer to the orthophoto. That is 3.1.5. Okay, refer to the orthophoto. Give the area of the demarcated area 6 in block A5 and A block. Give the answer in square kilometers. So whenever you are asked to do your calculations, okay, this is area. The first thing that you need to understand is, how do you calculate your area? Your area is length times breadth. Okay, all right. What are you using? You are using an orthophoto. You are using an orthophoto. Your area is length times breadth. You are using an orthophoto. What is the scale of the orthophoto? You need to have that information before you even attempt to answer this question. Is 1 is to 10,000. Of course, this is in centimeters, but my answer has to be in square kilometers. So I need to convert so that I know what is the equivalent of 1 centimeter in an orthophoto map scale. Okay, so I'm going to convert it to meters. It will be 100 meters. Where did I get that? 100 centimeters in a meter. So I simply divided by 100, then I got 100 meters. Then I'm going to convert it into kilometers. How many centimeters are in a kilometer? It's 100,000. So I'll say 100,000, okay? 10,000 divided by 100,000. What do I get? I'll get 0.1. Okay. So in kilometers now is 0.1 kilometers. Okay, so now that I have my scale with me, I have converted it. It's in centimeters. 1 is to 10,000 centimeters. I changed it into meters. This one on the map remains the same. It remains 1 centimeters. The only thing that is changed is what is on the ground, because what it means is 1 centimeter on the map represents 10,000 centimeters on the actual ground. 1 centimeter on the map represents 100 meters on the actual ground. 1 centimeter on the map represents 0.1 kilometers on the actual ground. So what is being represented on the actual ground remains this, it changes, but what remains the same is what is on the map. It remains a centimeter. Okay, so back to our question. Give the area of the demarcated area 6 in block demarcated area. This is the demarcated area 6 in block whatever it is. Okay, block A4 and 5 and B4. Give the answer in square kilometers. What are we given? Use the information. Length is 3 centimeters. So we have got our length. We are given the length is 3 centimeters. So the only thing that we need to find out is our breadth. Okay, is our breadth. This is in centimeters. Okay, we need to find our breadth. What is the, okay, the shortest side is what gives us our breadth. Okay, we're going to measure in centimeters. What do we have? I can see here, it looks like we have 2.2. It looks like we have 2.2 centimeters. Okay, we have got 3 centimeters for our length, then we have got 2.2 for our breadth. So our calculation now, yes, how it's done. So you say length times scale times length times scale. What is our length? Our length is 3 centimeters. What is our scale? Because we want our answer to be in square kilometers, so we are going to use 0.1 what? Kilometers multiplied by what is our breadth? Okay, sorry. What is our breadth? Is 2.2 centimeters multiplied by 0.1 kilometers. Okay, so it's 3 centimeters times 0.1 kilometers times 2.2 centimeters times 0.1. I usually do it like this so that I don't confuse myself. 3 times 1, okay? 3 times 0.1. What do we get? We get, okay, let me do it again. 3 times 0.1. What do we get? Okay, it's 0.3. So we're going to have here 0.3 what? Kilometers multiplied by 2.2 times 0.1. 2.2 times 0.1. What do we get? All right, we get 0.22. We get 0.22. Okay, let me just show it on the screen. 2.2 multiplied by 0.1. What do we get? We get 0.22. So 0.22. Remember, all this is in kilometers. This is all in kilometers. So we are now saying now our 0.3 multiplied by 0.22. What do we get? We are going to have 0.066. So our answer will be 0.066. The answer is in square kilometers. The answer is in square kilometers. Forgive my handwriting. 0.066 square kilometers. So it means you have your formula, which is length times breadth, and you have got your length, which is 3 centimeters, is given here. Then you also have your breadth, which is 2.2 centimeters. So you multiply 3.3 centimeters multiplied by 0.1, 2.2 multiplied by 0.1. Why are we using 0.1? Because our answer is supposed to be in square kilometers. So what is the equivalence of 1 centimeter on an orthophoto map if we convert it from 10,000? 1 is to 10,000 centimeters, 1 is to 100 meters, 1 is to 0.1. That's what we did. Or you can find your answer in centimeters, then you divide by 100,000. It's up to you. But this is the easiest way. First thing, when you get a map, convert it into these different units. Convert it into centimeters, into meters, and kilometers. You've been given your length, measure your breadth, then you say length times scale times breadth times scale. 3 centimeters times 0.1, 2 centimeters by 0.1. Here you get 0.3. multiplied by 0.22, then you get 0.02266 square kilometers that you add. That is your area. Give a reason why the expansion of the demarcated area, that is now question 3.1.6. Give a reason why the expansion of demarcated area 6 in answer B is limited into the east-southeasterly direction. So what usually happens is, guys, if you find out that you don't understand what is happening here, so what you need to do is you need to go back here, area of the orthophoto map, This will help you to understand. You can see from this, there is a river here. You can see there is a river here. Let's go there. There's also a river there. So the first answer will be due to the river. There's also a row of trees. But this is the area of the orthophoto. So you need to understand, if you go to your 6, there is a row of trees. That will be another reason. Forms a buffer zone. There is a recreational area, accept green belt. So these are some of the things that you have to scrutinize in order for you to come up with your answer. So that's how you do it. There is a river, rows of trees, which forms a buffer zone, and so on and so on. So that's your answer there. All right, let's move on to 3.2.1. It reads, refer to block F. Here we are now using a topographical map. Refer to F in C2 and G in D4. F, C2, okay? And G, where's G? Here in D4. The question reads, the temperature at F is in the center of the town is 2 degrees Celsius higher than at G. Name the concept that describes this difference. Remember, temperature of the urban areas is higher than the surrounding rural areas. That is your urban heat island. Obviously, you are given that the temperature of the urban area is higher than the surrounding rural areas. That is the concept of urban heat island. This is how they integrate the concept that you have covered. This is part of climate and weather. Okay. Then give one reason why the higher temperature density of buildings at F generally contributes to higher temperatures. This is, you have to know, how does higher density of building contribute to higher temperatures? That's what the question is all about. So heat will be trapped. It reduces the wind speed, it reduces airflow, there's a lot of artificial surfaces, there's a lot of multiple reflections. So all these can answer that question. Okay. Refer to blocks D2 and D3 on the orthophoto map. Explain how aspect of a slope determine the location of Rosepark at 7 on orthophoto map. Okay, so we are now dealing with this now at 7. So the first thing that you need to understand is, whenever we talk about the aspect, this is the angle at which the sun rays strike the slope. So in the southern hemisphere, north-facing slope are warmer than the south-facing slope. This is a concept of aspect under valley climates, okay? North-facing slope are warmer than the south-facing slope. So this is the concept that they're trying to integrate now. That's, you need to be very careful, okay? So they are now simply asking you that which slope is likely to be warmer and which one is likely to be colder. How the aspect of a slope determine the location of Rosebank on the orthophoto map, which means whenever we want to build settlement, we also take into consideration the issue of slope. Is it a warm slope? Is it likely to be cold? That is the temperatures that are found within that slope, or it can be a valley or whatever it is. Okay, like for example, we said that, okay, you're likely to have more houses on the invasion layer because it's warmer than at the bottom of the valley. Why? Because the temperatures can go beyond 0 degrees Celsius, where we can have frost. Okay, so that's basically what we are talking about here. So the question raised 322, how aspect of the slope determine the location of Rosepark at 7, the orthophoto map. This is where our 7 is. North-facing slope, obviously they're going to be warmer than the south-facing slope. So the answer there, 3.2.2, will be Rosepark 87 is located on the north-facing slope, which is warmer and receives more insolation, incoming solar radiation. Or the Rosepark 87 is located on the north-facing slope. That's the answer. Then the dam wall indicates that the river is flowing in a. All right. This is referred to H on B1. H on B1, H on B1. All right, so the first thing that you need to understand when it comes to the dam wall is it helps you to determine the direction in which the water is flowing or the river is flowing. The river will flow towards the dam wall. So you have to check where your dam wall is. Okay, so where your dam wall is will tell you the direction in which the river is flowing. You can see the dam wall is here. Okay, you can see the dam wall is there. Okay, let me see what we have here. 3.2.3, you can see it's going towards the south, but this is southwest. Okay, B1. Okay, it's going to south. Okay, this is southwest. You can B, it's okay. You can see the way it's flowing because this is the dam wall, southwest. Okay, so I'm going to take A there. I'm going to take, which is southeast, southwesterly direction. I'm going to take A because you can see north, southwest, east. It's towards the southwest. You can see what is happening there because we are looking at the dam wall. The river will flow towards the dam wall, not away from the dam wall. It will flow towards the dam wall. So your answer there is A. Your answer there is A. Okay. Someone can accept also southeast, but I'll go more on southeast because this is the river. You can see this is the dam wall. Okay, it's going towards this. We can also take southeast, okay, but it's flowing towards the south direction. Okay, then what else do we have? Refer to the way at I in A3 on the topographical map. A way is used, you are even told what it is. A way is used to regulate, control the flow of water in the river. Explain why the construction of the way was necessary. You have already been told why it's necessary. You have been told what it is. A3. Okay, so obviously this is your 3.2.4 is to reduce the risk of flooding due to the confluence of rivers. Okay, the one reason, reduce the risk of flooding downstream cultivated land, build up area, railway line and caravan park, or to reduce the risk of flooding. That's the point that is relevant there. Okay, then 3.2.5 refer to the section of Clape River 8 on A2 to 9 on block A5 on the orthophoto map. All right, we are talking about this. This is what we are talking about. Okay, this is what we are talking about. This river, you can see it's meandering. Okay, identify the fluvial landform. This is a meander where a river twists and turns. It twists and turns. It twists and turns. Mostly it's caused by lateral erosion, which is the erosion of the river from bank to bank. That's lateral erosion. You find it in the middle course and the lower course of the river. That's where we find it. The river has lost most of its energy in that part. Now it's eroding laterally. Okay. So the question is, identify the fluvial feature as a meander. Give evidence why this fluvial landform feature developed in this area. Obviously, we are looking at a situation where the land is flat, gentle. This is the lower course. Contour lines are far apart. That's basically what we are talking about is evidence to support that. Then give evidence, okay? Refer to block C5 on the orthophoto. Where will more erosion takes place at 11 than 10? 11 than 10. Well, erosion. So it's a matter of knowing where is the outer bank. The outer bank, that's where erosion will take place because water will be flowing at a faster speed. That is your undercut slope. Then the inner bank, that's where there is more deposition because water is slower. There is more deposition. That is your slip-off slope. So we are saying now where the outer bank is your undercut slope, the inner bank is your slip-off slope where erosion is taking place. So erosion, undercut slope, outer bank, then deposition, that is the inner bank, which is your slip-off slope. That's what it's all about. Then the vertical area photograph used to make out a photo map is, and obviously here we are talking about a higher resolution, which means because our orthophoto map is an image, it's a photograph. So it's to make it to be more clearer, it is supposed to have a higher resolution. If it has a low resolution, which means it won't be that clearer, it has to have a higher resolution. The reference of the topographical map represents the reference of the topographical map 3.3.2 is attribute, which is more descriptive. Okay, it describes, it gives more information about the topographical map. If it's spatial, we are talking about your vector data, you are talking about your coordinates, which is real georeference. That's part of your spatial. Okay, attribute is more descriptive. So that is your attribute there. How does this data in question 3.3 assist in identifying J on the topographical map? 3.3.3, it indicates what feature J represents in reality. What is feature J representing in reality? Okay, represents what feature J represents in reality. That's what it represents. Okay, yeah, what it represents in reality, that's what makes it an attribute. Okay, you can also talk about the reference shows that the symbol at J is an excavation. It's an excavation. It's even showing that it's a what? It's an excavation. You go to your key, it tells you that. So that's what it means. That distinguishes the similar land use features, mine dump and mine excavation, but it shows what is more descriptive. That's what it's all about. Define the term buffering, demarcation of an area along a geographical feature. Okay, that's what buffering is all about. Demarcation of an area or around a geographical feature. That's what it's all about. Okay, let's say this is a river, then there are rows of trees. That's part of buffering as well. Okay, how would buffering at 12 protect the quality of water in the Clay River? 3.3.5, it restricts development of the banks of the river. It decreases pollution from built-up areas, reduces erosion entering the river. It decreases eutrophication. Obviously, there are chemicals that are used in farming. This is what results in eutrophication. Okay, reduces salinity. Biodiversity of the river will be preserved. So basically, what we are saying is, when you're looking at Orthophoto 12C2, we are saying now, how does buffering protect? Which means we are demarcating along the river. How does it protect? Obviously, it restricts development on the banks of the river. Obviously, at some point, if we develop on the side of the river, it might result in siltation. The river being filled up with sand, decrease pollution from the built-up area. So that is protecting the quality of the river. Okay, that is part of river management. Okay, I would say that is part of river management. Restrict development of the banks of the river, decrease pollution of the built-up area, reduces eroded soil from entering the river, and decrease eutrophication and reduced salinity, and biodiversity of the river will be preserved. So, boys and girls, we have come to the end of our section B on our 2024 paper. I hope if you go through this, you benefit in one way or the other. If you have got any problems or any challenges in Mapwork, please just send a message. Then I can do any video on the concept that you feel confuses you or you do not understand. Thank you so much. Bye.